So in this revision session, we're going to look at the January 2019 booklet. So a sequence of figures is made from joining polygons with sides of unit length. The first three figures are shown below. So we have figure 1, figure 2, and figure 3. Now there are certain things that we can observe about these sequences. So in figure 1, the lines at the base there, the line at the base is 2, but in figure 2 you can see that it's 2 lines at the base, and in figure 3 there are 3 lines at the base. So if you want to draw the fourth figure, you should have 4 lines at the base. At the sides you can see it's a constant, just 2. On the outer you can see it's 2. At the top we have 2 in the first figure, but in the second we have 4. In the third we have 6 at the top. So in the fourth we should have 4 lines at the top. Okay, so we have at the bottom you can see it's going up like counting numbers, so it's n. So let's draw the figure. We should have something looking like this. Now let's look at the table that is given. Also, you are given a table where you are required to use this information here to complete the table. So let's have a look at the table. So in this column we have a figure, and in the second column we have the number of outer lines of unit length, and in the third column we have the perimeter. So in part B you are required to study the pattern in each row of the table, and each row relates to one of the figures in the sequence here on this page over here, and some rows have not been included in the table, so you are required to complete the rows numbered 1, 2, and 3. So let's make this a little bigger. So what we have there is, so let's examine our table and use the information to fill out the table. Okay, so it says that each row represents a figure and some number patterns there. So in row number 1 relates to figure 1. So what we have there at the base, we have 1 line at the base, and at the side we have 2, and at the top we have 2. So this one here represents the line at the base, and at the side that represents 2, and at the top that represents 2. When you add up everything you get 5. For figure 2, at the base we have 2 lines, so this 2 here represents the 2 lines at the base, and at the side on the outer we have 2 lines, that's a constant, and at the top we have 4 lines. So we have base, the vertical sides on the outer, and at the top. So for the third figure we have 3 lines at the bottom, which is this one, and then at the side on the outer here we have 2, and at the top we have 6. Add them up, we get 11. So now you're required to complete part 1. So let's look at part 1 and see what that's all about. So in part 1 you are required to complete the section with figure 6. So like we realize that the base of the figure is counting numbers, so we start with 1, then 2, 3, 4. So figure 6, it's like the nth term for that would be just n anyway. So figure 6 is just 6, and at the sides we have 2, and at the top here you can see that it's a 2 times table, so we have 2, 4, 6 at the top, then 8. So at the side here we have 2, 4, 6, so it's the 2 times table, which is just 2n. Okay, so if we have the 6th figure, it's going to be just 2 times 6, which is 12. Okay, and you add up that. Okay, so when you add up this you get 20, right? So we get 20 for that. So we can fill out the table there for 20. So the perimeter there would be 20. We'll add up all of them. Now, they gave you 65 as a perimeter, but you need to find out what figure it would be and also the pattern there, the number pattern. Now, let's examine the formula for the perimeter there. We have 5, then 8, 11. It's going up by 3. So we can see that it's a 3 times table. So if it's going up by 3, you write 3n. Alright? And then you examine this number if it's going up by 3. So we start with 3 there and you examine this number. It's bigger than 3 by how much? 2. So the nth term for it would be 3n plus 2 because it's bigger than the 3 times table by 2. You add 2. So 3n plus 2. So this formula here represents the nth term formula for the perimeter. If they gave the perimeter as this, it means that it would equal to 65. So all you need to do is to solve for n here to figure out what should be here. So by taking 2 both sides, you get 63. So 3n would equals to 63. Therefore, n means that you divide by 3, so you get 21. So here we would have 21 for this part. And remember the base of the shape is just n. So if it's 21, n is 21, so you just write 21 there. And at the sides, we just always have 2, which is a constant. And then because it's a 2 times table, so you just write 2 times 21, which is 42. If you add this up, you should get 65. Now, the next bit, which is part 3, they want you to write the nth term now formula for this. So, for the base, you can see that's n. So you're going to write n plus the constant 2 plus this sequence is a 2 times table, which is 2n. So you write 2n. So it's n plus 2 plus 2n. And for this one, because it's going up by 3, it's going to be 3n and it's bigger. This 5 is bigger than 3 by 2, so you add 2. So the nth term for it is 3n plus 2. Okay? So in part C, you are required to show that no figure can have a perimeter of 100 units. So this formula here represents the perimeter. So if they give you 100 units to find out whether there's any figure that has 100 units, all you need to do is to equate this to 100 and see if you find n. If n is a whole number, it means that it would have a perimeter of 100. If it's not a whole number, then it's no figure would have a perimeter of 100. So let's see what we get there. So we have 3n plus 2 equals 100. So we want to take 2 both sides, so we get 98 there. So 3n equals 98. So to get n, you divide both sides by 2. Okay, so when you divide both sides by 2 there, you get 32 and 2/3. Which means that no figure would have a perimeter of 100 because you do not get a whole number. You're getting some decimal there, which is 32.66 recurring, right? So no figure would have a perimeter. No figure represents 32.6. It has to be a whole number. So here ends question 7.